100,000 galaxies. 100,000 galaxies.
Increase the field of view. Increase the field of view.
Key technologies.
We also get a glimpse to the future.
Several science projects simultaneously.
The aim of APERTIF is to increase the survey speed of the Westerbork telescope. And the way to do it is to increase the field of view. Currently the Westerbork telescope has a field of view of about the size of the full moon. And that's reached by using a single receiver for every reflector antenna here in Westerbork. By replacing the single receiver per reflector antenna with an array of receivers, we can increase that field of view. We're at a very special location at the moment because we're right in the center, in the focal point of one of the Westerbork reflector antennas. What we see over here is a full-size phased array feed mounted in one of the reflectors of the Westerbork telescope. Over here I've got a smaller scale prototype on which I can also demonstrate the front side of the phased array feed. Over here you can see the small wideband antenna elements of which the phased array feed is composed. And as you can see over here, an element consists of a wideband antenna element with a very special low noise amplifier attached to it. These low noise amplifiers are designed and tested here at Astron and operate at room temperature. Every element in this array has about the field of view of the single receiver that's now installed in the Westerbork telescope. And by combining the responses of all these elements, we can increase the field of view of the Westerbork telescope to about 25 times the size of the full moon.
Because of the capabilities of APERTIF, several science projects can be done simultaneously with APERTIF. So the same observation serves very different research groups for very different purposes. One important consequence of the fact that APERTIF will allow radio astronomers to do large surveys is that we will be able to sort of catch up with other areas of astronomy. In many wavebands, optical and other wavebands, large area surveys have been done, of which the data are available through open access archives. And with APERTIF we will be able to catch up for radio astronomy so that radio astronomy can play its proper role in this kind of science.
For me personally, I'm mainly interested in the role and the fate of gas that was formed during the Big Bang in the formation and the evolution of galaxies like our own Milky Way. So APERTIF will observe in great detail the distribution and the movements of gas in 100,000 galaxies. And by observing 100,000 galaxies, we can investigate in great detail what the role and the fate is of this gas as it falls into galaxies and when it is removed from galaxies, because stars form out of gas and galaxies consist of stars. So by observing and studying the gas, we will learn something about the origin of galaxies, of stars, and eventually our own Sun and our own Earth. With Westerbork, we've been able to observe galaxies as they were 2.5 billion years ago in time. And we can see here the great structures in the universe along which these galaxies are aligned. With APERTIF, we will be able to observe 500 times larger volume of the universe as we see here. And that will really enable us to get a much better view of how these galaxies are distributed.
Another interesting aspect of APERTIF is that it not only enables new astronomy in the coming years, but it also helps to prepare new technology that we hope to apply in the square kilometer array, a huge radio telescope, 100 times more sensitive than any telescope we have now, and that we hope to build in the next decade.
The development of the APERTIF has a long history, starting at the end of the 90s with some other programs. And research engineers and 10 research engineers like Mariana Ivashina already was involved. European Union was involved through earlier programs like FP5 and then FP6. And only in 2005-ish, APERTIF became really a project for the purpose of Westerbork only. However, technologies developed in this context are very much useful for the SKA, the square kilometer array itself as well. And actually it is one of the key technologies being studied for the application area called square kilometer array.
Well, I think APERTIF is a very important step forwards for radio astronomy in general. The technology, of course, is important. Developing new technology, especially new innovative technology for the SKA. We use innovative technologies to build the best possible telescope at this moment. It takes some risk, but with telescopes like APERTIF, we reduce that risk to a minimum. And we also get a glimpse to the future, the kind of science that we can do, hopefully at the end of this decade with the square kilometre array.